Okay, hi and welcome. These are video notes 8.1 and 8.2, which is the properties of exponents. So we're going to actually explore properties here quite a bit. And we're going to tack on scientific notation, something that you should know from your science classes / some of your old math classes, but we're going to talk about them today. So what I'd like you to do is we're going to look at this investigation. And I'm going to pause the video here, and I'm going to have you do this, which is, if you need to, use your calculator. But I want you to fill in this chart here, starting with the 2x, or 2 raised to the x power, 5 raised to the x power, and 10 raised to the x power. So you're going to do a little exploring, and then when you're all done, you're going to come back here, and I will meet you. Okay, so we're back. You've had a chance to fill in your chart now. Should look something like you got here. If you look at the first 3 rows here, you'll notice that no matter what the base is, that you did kind of the same operation, right? This means 2 times 2 times 2, or 8, or 5 times 5 times 5, which is 125. And again, same thing for 10 would equal 1,000. And you'll notice that the first 3 rows are nothing more than you would expect. You might not have been aware, or you might have forgotten, that anything that you put in, or if you didn't remember this part, you put in your calculator, you would find out that anything to the 0 power happens to be 1. That's a rule that we're going to highlight today. And then one thing new that you might have learned is that you would have seen that anything to a negative exponent, so looking at 2 to the negative 1 or 2 to the negative 2 or any of these really, what you would have found out is that it seemed to do the exact same thing that was going on here, but it did it underneath 1, or making it a fraction. And that's really all it does. It's still the same exponent. It just is telling you to move it to the denominator, which is where we're going to get kind of our second concept, which is what the negative is telling you to do, is to move. And that's really all it does. So let's take a look at a couple of these here. And you'll see that number 5, looking at number 5, it says 2 to the negative 1. And again, let's get this idea of move and extrapolate it. Anytime you see a negative exponent, what I want you to do is circle it and the base that it goes to, and I just want you to draw an arrow to move it. What do I mean move? Well, really, any number can be a fraction. You can have the number in the top, you can have the number in the bottom. If it's just a number, we put it over 1. So any number can be thought of as a fraction. Wherever that negative exponent is, can be any negative exponent, doesn't have to be negative 1, you're going to move it. So if it's in the denominator, it goes to the numerator. If it's in the numerator, it's going to go to the denominator. Okay? And that's kind of what this rule right here is showing us. So if we look at 2 to the negative 1, it's saying take 2 to the negative 1, move it to the denominator, and then put your power as a positive now. So that's the other part. So move it, make it positive. So if we look at number 6, it's 2 to the negative 2. Again, we're going to take 2 to the negative 2, we're going to move it, and we're going to make the exponent positive, or 2 squared. And the same thing over here. 2 to the negative 3 is going to be moved to the denominator, and it's going to become 2 cubed. Now, we wouldn't leave those like that. Obviously, we'd make this 1/4, and we'd make this 1/8. But just to elaborate on the idea, what's actually happening? It's a movement. So let's look at some other basics that come from exponents. Again, exponents, the key term here is the base. Base, then, is the number that we're multiplying by. So in this case, 2 times 2 times 2 is going to tell us that the exponent, then, needs to be the number that we're multiplying by. So how many times this base is multiplied to itself? There should be a multiplication in there. We'll add it in right there. Multiplication to itself. So in this case, 2 times 2 times 2. 2 is multiplied by itself 3 times, so it becomes 3. So if we look at the next little quick example here, 5 times 5 times 5 times 5, that's 4 times, or 5 to the 4th. And these parentheses are key. Notice that it's a negative 3 inside the parentheses, and it's not 3 like this times itself negative times. So what we want to do here is count these negative 3's. There's 5 of them, so we're going to say to the 5th power. What you'll learn here is that even powers, looking at this, and this is an odd power, so a result for this answer will be a negative number. Okay, because it's odd. So think of just the negatives. There's one negative times this negative. They're going to make a positive. This negative times this negative, it's going to make a positive. And then there's one negative left over. So however many times we multiply this, if it's an odd number of times, we're going to have one negative left over. Doesn't matter what the odd number is, we'll have one negative odd number left over. If it's I'm sorry, and that was for the odd powers. For the even powers, it's going to come out to be positive. So if we multiply this again by another -3, this will go to 6 over here, but our negatives now will all cancel out. We've got 1, 2 here, 1, 2 here, and 1, 2 here. All of those negatives will turn positive. So this answer would result in a positive answer. Okay, so just keep track of that. That's a nice little tidbit to add to your stamp sheet. I'll write that in right here. That would be something that I would add in there. All right, so here's those two rules we found above. Any base at all, A, in this case, is raised to a 0, it'll always result in 1. Okay, and then the other rule that we found looking at that exploration is that if there is a negative exponent, that it's telling you to move its positions. And you can see here that it's moved and then switch signs. Again, here's a nice little quick summary of that. Negative exponents equals move position, switch signs. And it doesn't matter if it's in the denominator or the numerator. So here is if in the numerator, and this is if it's in the denominator. Okay. So it doesn't matter. It just says move positions. Again, I probably would take this and add this into my stamp sheet as well. Or on the back of it, your stamp sheet. So that you have a quick note, a quick reminder of what actually comes out of this section. All right, so let's do some quick examples. 5 to the 0 power is 1. If we look at 3 here, it doesn't matter what the number is, it's raised to the 0 power. And that's the secret. It doesn't matter what the number is. It could be any number you want it to be. Gosh, I could take a smiley face for that sense, raise it to the 0 power. It's going to be equal to 1. Okay, so now let's look at question number 4 here. You'll notice that I've got a negative exponent. And again, I'm going to circle the part that the -4 is 2. And we'll explore that a little bit more in the next coming days. That'll change. But in this case, this 3 is raised to the -4th power, so I'm going to move its position. Since there's nothing in the numerator left, I'm going to use 1 as a placeholder. I'm going to put 3 to the 4th in the denominator, and 4 becomes positive. Okay. Same thing over here. I already set it up for us. It says move and switch. Again, if there's nothing there to hold its numerator space, because there it is in the numerator, -8 raised to the -1 power over 1. I'm going to move it and switch it. So the negative on the 8, though, doesn't change. Okay, that does not change. I mean, if we clean this up, it would be 1 over -8 or -1/8. Okay, looking at 6, same idea. Take it, move and switch. I like visuals. There you go. 1 is a placeholder. It's holding its location. And really, it's going to be 1 over the 7th. Now, looking at this one, we need to be cautious with this. You might want to start. Maybe this is an example you add in, because this is where some kids get confused. Now, notice above, in my notes, I'm going to scroll up. When we're looking at this example here, the negative is in parentheses, and that its power, it's also part of the power. In this one, it's not. The 2 is the only thing raised to the 4th. The negative is not. So even though this is even, and our rule up here says even powers of negative numbers is positive, this isn't a negative base. This is a positive base multiplied by -1. So let me rewrite this for you so you can see it. This really equals -1 times 2 to the 4th. So you have to be very careful with this one. So the result is 2 to the 4th, which is 2 times 2, which is 4. 4 times 2 is 8, and 8 times 2 is 16. It's -1 times 16, or -16. This one stays negative because the negative's outside the parentheses. Okay, so that's the notes. One more quick question, sorry, I lied to you. One more quick question. It says, why can't you use 0 as a base? Well, let's explore that quickly. If I take 0 to the 2nd power, well, 0 times 0 is 0. 0 to the 1st power is 0. This actually should be a 0 here. So 0 to the 0 power, our rule above says that any number, non-zero of course, should be 1. So this would break our rule, but it wouldn't make any sense to make that 1, would it? It would not. And then this one gets complicated too. This says move its position. So if we move that position, it's 1 divided by 0. You can't divide by 0. That tends to turn out to be undefined. So we have some rules here. Obviously, 0 is not one that we can include in our exponent rules. Okay. So there's a couple of questions for homework on here. I didn't write them on here, and I don't have them at this current second. Let me hold on, and I'll go get them for you. Okay, I got that typed in for you. So it's going to be page 397 and page 402, just 4 questions each. 1 through 4 all, and then you're going to do 1, 2, 7, and 8. They should only take you a couple of minutes. So there you go. We'll see you in class. Thanks for watching.